Oh, okay. The video's posted up on Canvas. I know that. And the video's on YouTube and gets posted to Canvas. So we're looking at the right-hand one. We gotta factor everything before we multiply so that we can do some simplification. So I'm gonna bring it in over here. And we're gonna get our two fractions and we're gonna simplify. So this one, our numerator on the left fraction, how does that factor? X minus 4, x plus 4. Or x plus 4, x minus 4. Doesn't matter the order. But this is a difference of squares. X minus 4, x plus 4. Because this is a difference of squares. Good on my stylus. Okay. This bottom one on that fraction, can I do anything to simplify this? I mean, you could put it as x times x if it really helps you. Totally fine. You can do it as that. I just heard somebody say that. X times x. You don't have to do that. Absolutely fine. You can. Totally fine. How about this one up here? Green. X. It has a GCF of x. So we have x times x minus 4. That's our leftover bit. And then the denominator on that one, it's not one of our special patterns, so we are going to have to actually do that manually. Where we have a pair of numbers that multiplies to be negative 12, adds to be negative 1. What is that pair of numbers? Negative 4 and positive 3. Since our a value is 1, we can take our shortcut where we put our x minus 4, x plus 3. Questions on the factoring part? Because I know we went through that kind of fast. Now we're looking at our multiplying and simplifying stuff. So since we're multiplying these two fractions together, that is essentially just smashing them together into one giant fraction, and we can simplify top and bottom. What do we have that simplifies? I have an x minus 4 that cancels out. And I can cancel out one of the ones in the numerator, not both. It has to match exactly top and bottom. What else simplifies? What you got? An x. Got an x here and an x here. Those cancel out. Is there anything else that simplifies? Is there anything else that simplifies? Nope. So our simplified answer, we're going to rewrite it with everything that's been crossed out gone. We've got our x minus 4, got an x plus 4, and in the bottom I have left over an x and an x plus 3. And we're going to leave it in factored form. Don't remultiply it out. That's just doing too much. Stop right there. That's your answer. This is done. Boop, 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 boop. Okay, so multiplying, not super duper complicated, but it just takes a little bit to rewrap our brains around it. Questions on this one? Okie dokie. Boop. We're going to look at some dividing now. I'll zoom it in because I know these are small and busy. So looking at this one first. Very similar vibe. Factor everything. And while we're factoring everything, we can remember what we're going to do with fractions and division. What is it we do with fractions and division? Keep, change, flip. Where we keep our first fraction the same. We change our sign and we flip this fraction, the whole thing upside down. So our first fraction stays the same. We're just going to factor it too. So this numerator, what is this one in factored form? A minus 3 squared, which you can either write as a minus 3 squared, or you can do it like factor style where we do a minus 3 and a minus 3. They are exactly as equally correct. You can do it as the square, or you can do them separate. Does not matter. Our denominator here is just an a minus 3. So there's not really anything I can do with that. I'm just going to put it inside parentheses. Since we know we're simplifying things here, we want everything to be in parentheses so we remember which things are factors and which stuff we haven't gotten to yet. Because it has to be in factored form in order for us to simplify stuff. Has to be in factored form for us to be able to simplify. Has to, has to, has to. So then we are coming through our keep, change, flip. I'm going to change my sign to a multiplication. And when we flip, I take my denominator and it goes to the numerator. So when we put this one in factored form, what are we going to have? Super close. Nope, yep, you're exactly right. Sorry, I was doing it in my head. When in doubt, we're going to write it out. So we have our minus 18, positive 3, and you're exactly right. We've got our positive 6 and negative 3. Doing it in your head, it's sometimes really easy to flop those signs. Y'all got a question, guys? We good? You got a question? Okay, just checking, because you cheaty chatting. So we have our a plus 6 and our a minus 3. It goes on the top because we flipped this fraction, which means our numerator on this right fraction goes in the denominator. And you can, again, either write it as a square or you can write it out as a factor over here. Either way is fine. I'm going to write it out because it makes it easier for the crossing out parts. But you don't have to. You can absolutely put that as a minus 3 squared still. It's less writing. Questions on the factoring part? All right, now the simplifying. What do we have that simplifies? A minus 3. So I'll pick a pair. So I've got one pair that is top and bottom. What else simplifies out? Another set of a minus 3 and a minus 3. What else simplifies out? Another a minus 3 over a minus 3. Anything else? No. So what is this division fully simplified? Just a plus 6. That's the only thing left. That is a whole lot for a plus 6. But it is what it is. Yep, just simplifying. Okay. All right. One more of the division, and then we will walk away from it for a while. I know, they're beasts. And this one is beastie. Beastie. I'm going to give you guys a second to write it down. There's a lot of pieces and a lot of variables here. I'll give you guys a second to write it down because I know it's a lot. And I'm going to do the exact same process as before where I put my fractions down here. We're going to switch it to multiplication with our keep, change, flip. And I'm just going to factor all my pieces with all my color coding. I color code so that if you guys try and pull up the notes later, you guys can see which pieces are attaching to which pieces. So this First one, our left-hand numerator. What is going on there? It's a difference of squares. 4x squared is a perfect square. 9y squared is a perfect square. This is difference of squares. So what are my factors here? 2x plus 3y and 2x minus 3y. Just because it's got variables doesn't change the pattern. Still our difference of squares. How about this bottom one? It's our difference of cubes. I'll call it a DOC, difference of cubes, which is another special pattern. It's just a different special pattern. With our difference of cubes, since for some of us that's going to be really new still, what is cubed to make 8 cubed? 2. So we have 2 and x here. What is cubed to make our 27y cubed? 3 and y. So that's our A and our B pieces. Our A is the 2x, our B is the 3y. So when we're putting it together into its factored form, we also need to do the SOAP piece, where we have our A term, where we then use our same sign. That's the S of SOAP. So we're going to use minus our 3y. Then we take our A squared, so the 2x squared, which gives me 4x squared. We're into our next sign. So we did our same sign. Now we're doing our opposite signs. We're going to have a plus. My A term times my B term. So my 2x times my 3y gives me 6xy. My last sign is always positive. So we get another plus. And I take my B term squared, 3y squared, which is 9y squared. So our difference of cubes is going to take some practice, and it's going to show up in these quite a bit. What's up?
Can you just like write 2x minus 3y 3 times?
No, because it is different. 2x minus 3y cubed is different than the difference of cubes. It would be nice if we could, because if I try and factor this thing, it's not going to come out as 2x minus 3y again. In fact, it doesn't factor. I wish we could do that. That would be a lot easier. But it doesn't work. So now we're going to take our right-hand fraction. Questions on our cube real quick. Or anything of these pieces. Okay. So we're changing our sign, which means I'm flipping my next fraction because we want this to be multiplication. So I'm going to take my denominator from my right-hand piece and put it on the top. We've got our 4x squared plus 6xy plus 9y squared. That sure feels familiar. Nope, don't do that. Don't cross multiply. I was going to say, you're right on the edge of it. Just be careful. All right, so we're going to take our numerator up here and put it as our denominator, where we have our 2x plus 3y, and you can either put it as squared or you can write them out. Plus 3y. I like to write them out because it's easier for the simplification. We could try and factor the grossness that is pink, but it is familiar. It also won't factor, so like, because what do we notice in our fully factored bottom multiplication piece? What do we have that can cancel out?
2x plus 3y.
I got a 2x plus 3y that can cancel out. This guy and this guy. I got a 2x minus 3y that can cancel out. This guy and this guy. And the hot mess can cancel out. That hot mess and that hot mess. So what do we have that's left? 2x plus 3y. Is my answer 2x plus 3y. Like this? 1 over. This guy's in the denominator. 1 over 2x plus 3y. It doesn't get to move up just because it's the only thing left. So almost everything canceled out, but we are left with a fraction here. 1 over 2x plus 3y. So these two problems were hot messes. And they got us down to fairly simple statements, but they were messes at the beginning. Questions about these two? Okay. We will leave division. No offense, that don't mean it's going to get better. Because we're going to do some addition and subtraction. Yay! So we're going to remember what we need to do for fractions for addition and subtraction by doing very, very simple ones. I don't ever toss you straight into polynomials. We're going to go, wait, what do I do again? With something a little bit easier before we go into polynomials. Because if I'm trying to add together 3/4 and 2/6, what do we need to do? Common denominators. So we have several different ways we can go through this. You can either multiply both of them by the denominator of the other. Like I could straight up multiply, whoa, that's not a pen. I could multiply this side by 6 over 6 and this side by 4 over 4. Definite, totally, absolutely valid strategy. You will have a lot more things to simplify that way. If we go for our least common multiple, it will save us work. So what is the least common multiple between 4 and 6? 12. So what do I need to multiply this left fraction by to get the 4 to be a 12? 3. So we're going to multiply this one by 3 over 3. The right-hand side, what do we need to multiply it by? 2 over 2. Again, I have to multiply by a 1. We talked about this when we first talked rationalization. Have to multiply it by 1. We don't have an equal sign to hit both sides of, so we can only multiply by 1s. So we're going to wind up here with 9 over 12 plus 4 over 12, which means what is our answer here? 13 over 12. Got to get a common denominator, and then we're adding our numerators. Once we have the common denominator, we can just add the numerators. Same vibe with the subtraction. What is our least common multiple for the right-hand piece? 15. So our least common multiple is going to be 15. What do I need to multiply the left-hand fraction by in order to make this be 15? 5 over 5. And what are we multiplying the right piece by? 3 over 3. So we wind up doing exactly what I showed you first, where we multiply by the other denominator. But it's still getting us to that least common multiple. So what are we going to get on this one? 7 over 15 as your final answer, because we wind up with 10 fifteenths over 3 fifteenths, and we're subtracting. So we get 7 fifteenths. So if we started with adding and subtracting fractions with numbers, we wonder what we're going to do next. We're going to toss some polynomials in there. Woohoo! Oh. All right, starting with the left one. I'll zoom it in because I know especially with these rationals, they get very small. So here's our first one. Got 5 over 4x squared y plus 3 over 14xy cubed. And once you get it written down, our first thing is going to be to try and figure out our least common multiple of our denominator. What is our denominator going to wind up being? Look at it very closely, very carefully. $28 would be the least common multiple of 4 and 14. X squared and x means we need to have at least an x squared. Y and y cubed means we need a y cubed. So 28 x squared y cubed is our least common multiple. I highly recommend finding your least common multiple first because that'll make it a lot easier to figure out what we're multiplying by. You can absolutely multiply by whatever the other denominator is. It's a valid strategy. You're just going to have a lot more simplification to do. So, now that we know our least common multiple, what do I need to multiply this left-hand denominator by to get to that least common multiple? 7x. Oh, do I need to multiply by an x?
No.
Nope. We already have an x, so we just need our y squared. So we're multiplying by 7y squared. What do we need to multiply this right one by? I'm going to put it down here. 2x. So we're going to multiply by 2x over 2x. So I'm going to do those. We're going to wind up with our denominator of 28x squared y cubed. What's my numerator for the left fraction? 35y squared. What is going to be my numerator over here? 6x. So when we add these together, it's going to give us one fraction. 28x squared y cubed is my denominator. What's my numerator going to be?
35y squared plus 6x.
35y squared plus 6x. I can't combine them together. 35y squared plus 6x. Is there anything that can simplify out? Can I factor anything? And anybody?
7.
I can't divide by 7 because the 6 doesn't divide by 7. And there's addition up there. So we can only simplify if things are factored. So there's nothing that can simplify there. Everything would have to have an x for us to be able to simplify it. It's important to look, but if you've used the least common multiple, and it is actually the least common multiple, there should not be any simplification. If there is simplification, we weren't quite at the least. Okay? But that's, I think, the only one we do are with the monomials because the polynomials take a lot longer. Okay. Polynomial time. It's a subtraction. And at least the first one's just binomials, so we don't have as much factoring. We've got our x plus 2 over x minus 6. And we're going to take away the x squared plus 5x plus 14 over x squared minus 2x minus 24. So our first step needs to be to figure out our least common multiple. But that means I need to know what pieces make up our denominator. So our first step is to factor everything. So we're going to put this in factored form just like if we were going to do it as a multiplication. So factor everything we can. Our first fraction doesn't change. We're still going to wind up with our x plus 2 over our x minus 6. I'm still keeping my subtraction here. And we're just going to factor these pieces. So on this top one, on our numerator, we've got that it multiplies to make 14 and adds to make 5. And is that got a sign wrong on it somewhere? It feels like it's got a sign wrong. Yeah, that does not. What the heck was I doing? I have it down here, and I like straight up missed a thing. I think it's supposed to add to be 8. That 14's an 8. No, that's what the heck is that?
Shouldn't it just be negative 14?
Yeah, I think if we make, but then it won't.
It could be minus.
That's fine. Let's make it negative 14. If that works, let's go for it. Something that factors. It genuinely, the numerator's not super important. It's the denominator that's important. That's called, I made a mistake in my notes last year, too. Oh, no, that doesn't factor. It's okay to not factor. It doesn't factor. Leave it as not factoring. Sorry. Leave it as not factoring. Multiplies to make 14, adds to make 5, it doesn't happen. There was a point I was showing us later. Got it. I see what I did now. That's called I haven't looked at this in a year. So, sorry, took me a second. Leave it as not factoring. X squared plus 5x plus 14. She don't factor, she don't factor. Denominator. Let's look at this one. Multiplies to make negative 24. Adds to make negative 2. Negative 6, positive 4. X minus 6. X plus 4. Yes. So, the numerator piece doesn't matter. It's okay. We're looking at our denominator. Trying to figure out our least common multiples on these denominators. What is our least common multiple going to be? X minus 6 and x plus 4. Those are the two pieces that get multiplied together. So do I need to multiply this fraction by anything? No. What do I need to multiply this one by? X plus 4 over x plus 4. When we are doing addition and subtraction, we're going to leave our denominators in factored form, but we do need to multiply out the numerators so that we can do the addition and subtraction. So we're going to wind up with our x plus 4, x minus 6, and this fraction isn't changing. It's minus 6, x plus 4. Our numerator is going to stay exactly the same on the right-hand side, our x squared plus 5x plus 14. What is my numerator on the left-hand piece? I'm going to multiply it out. X squared plus 6x plus 8. So now that I have that common denominator, I can do my subtraction. We're putting this into one single fraction. So now we're going to have that common denominator. It doesn't matter which order we put it in, x minus 6, x plus 4. When I subtract the right one from the left one, what are we going to have? We have the x squared minus x squared. Those guys are going to eliminate out. They cancel out. 6x minus 5x is just 1x, or x. And then 8 minus 14. Minus 6. 1x minus 6. Whew, we're done, right? Why not? Because I've still got more simplification I can do. 1x minus 6 is the same thing as x minus 6. That's why I decided to go back and have you not change it. Because the x minus 6's can cancel out here. We can simplify. So even when we do get to our least common multiples, it is possible to still have simplification. It's just not super duper common. So our final answer is 1 over x plus 4. And I know these are a bit of a mess. Bit of a mess. We're going to practice these a couple more times because these things are weird. And there's a couple in the homework that are like, whew, crazy. So questions on either of these two? Okay. So we've got very similar to one we just did and a wonky-ish one over there. And we'll see if we can hit the uber wonky one next. All right. So here's our next one. Got x minus 4 over x squared plus 5x plus 6, bless you, plus the fraction that has x minus 1 over x squared minus 4. So we're going to start with factoring. So my numerator on the left-hand side isn't going to change. This guy doesn't have anything we can factor. Our x minus 4 is just going to chill. How is my denominator going to factor here? X, so multiplies to make 6, adds to make positive 5. We have x plus 2 and x plus 3. On the right-hand fraction, my numerator won't simplify. It's just going to be what it is. I'm just going to put it in parentheses so we can see stuff. And what's my denominator? This guy factors. X minus 2x plus 2, or x plus 2x minus 2. Doesn't matter what order. X plus 2, x minus 2. It's a difference of squares. The factoring part is important, so make sure we are being careful with that. So our next thing we're going to look for is trying to figure out our least common multiple of the denominators. What pieces do the denominators need to have in order to be the same? X plus 2, x plus 3, and x minus 2. So they need to all have all three pieces. So looking at the left-hand fraction here, what do we need to multiply this one by? The x minus 3. That piece is missing. X minus 2, sorry. I said it wrong. X minus 2 over x minus 2. That'll give me all three pieces in my denominator here. On the right fraction, what's it missing? The x plus 3. We need to add in the x plus 3 on this one. X plus 3. So again, we're going to leave our denominators in factored form, but we do need to multiply out our numerators so that we can simplify. I'm going to do this in one big fraction just to reduce the amount of writing that we have. Our denominator is going to be our x minus 2, our x plus 2, and our x plus 3. Need another color. Let's go red. So when we multiply out this numerator, what are we going to have? X squared minus 4x minus 2x, so we're going to wind up with minus 6x plus 8. And then we are adding that to this piece multiplied out. Multiplying that guy out. Yep, so we have our x squared plus 3x minus 1x. So plus 2x minus 3. If you take a couple of steps to do that where we multiply it out, then combine some like terms, that is absolutely fine, absolutely valid. We take a couple of steps, totally fine. We're just trying to multiply things out. Because now we need to simplify it. We've got this addition going on here. Our denominator is still the same. We've got our x minus 2, x plus 2, x plus 3. What does our numerator simplify to? 2x squared minus 4x plus 5. Can I factor that numerator? Let's check and see. When in doubt, check it out. So we would need to see if it multiplies to make 10, adds to make negative 4. Nope. So that's our answer. It's always a good idea to check. It is not super common, which is why my brain did not jump to it instantly on that first one that we did. It's not super common, it's super rare. But it is possible. Okay, so I want you guys to write this next one down. I want you guys to try and do it. We're not going to work through it together right now. We'll start with it tomorrow because it's a really good one to try because there's a couple of tricksy bits about it. But we'll start with this one tomorrow, so I want you to write it down, see what you guys can come up with, and we'll talk it through tomorrow. Okay? Because we have 4 minutes left in the period, and I don't want to speed run it. Where? Yeah. We will do 2 more of these kind of wonky problems before we finish out one for tomorrow. Since we will not finish this section today, the homework is not due tomorrow. So the homework, you'll get an extra day on. We're going to push it back till Thursday. I'm never going to make you turn in the homework the same day I teach you the thing. Like, nah. What's up? I will zoom it up. That one? See it? Okay. So yeah, homework 1-4 we do on Thursday. Barring catastrophe where we don't get through stuff tomorrow, but we should be able to finish it up tomorrow. Like that should be fine. Yeah, I know. I'm gonna put that away. It's gonna need over here. We are. Okay. I think that's where I wound up stopping last year too, because I've got a random post-it note right there. This one. Okay. What's up? Do you have a study hall? Okay. Period, like a study time? Any lessons that you guys like have?
Wait, no, I mean, I have
Like A's and study time?
yeah, use C.
C and study time? Okay.
Yeah.
Today? Or do that tomorrow?
Headed to the
So just remind me then on a regular.
That's my dad's
Sneak in through.